Hey, welcome back. Hope everyone had a fun and safe 4th of July weekend. Today should be July the 6th, and we're going to be talking about prime and composite numbers. But before we jump into that, let's do some quick calculations and see how fast we can do them. All right, I'm going to give you a problem. I'll say it 2 times, and then the second time I'll give you the answer. All right, we have 4 plus 11 divide 3 plus 14 times 2 plus 2 equals 4 plus 11 divided by 3 plus 14 times 2 plus 2 equals 40. All right, 7 plus 8 minus 5 times 6 plus 9 minus 4 minus 15 divide 2 divide 5 equals 7 plus 8 minus 5 times 6 plus 9 minus 4 minus 15 divided by 2 divided by 5 equals 5. All right, last one. 12 plus 13 divided by 5 plus 6 minus 7 times 3 times 2 divided by 3 equals 12 plus 13 divided by 5 plus 6 minus 7 times 3 times 2 divided by 3 equals 8. Well done. All right, let's do a quick review on some fractions here. We're going to start with the addition of the fractions. So we have a mixed number plus a mixed number. So let's start with the fraction part. We have 7/9 and 1/3. Now, remember, when we add and subtract fractions, we must have a common denominator. Well, I have a 9 and I have a 3. That means they're not common, so we need a common denominator. Of 3 and 9, let's go with 9 because 9 is a multiple of 3, and 9 obviously is a multiple of 9. So 7/9 will stay 7/9. Whatever I do to my denominator, so 3 times 3 equals 9, I must do to my numerator, so 1 times 3 is 3. I add my fraction, 7/9 plus 3/9 is going to give me 10/9. We'll talk about this in a minute. Remember, that's an improper fraction. My whole number is 4 plus 8 gives me 12. Now, can I leave my answer 12 and 10/9? No, you're right, because this is an improper fraction. So I must change this. So 10 divided by 9. 9 goes into 10 one time. I get 1 and 1/9, so I take this and add it to my 12. My final answer is 13 and 1/9. All right, let me erase this out of the way, and let's do a multiplication. 2 sevenths times 56. Well, 56 is a whole number, and we're doing fractions, so we must put this over 1 to make an improper fraction. Now, I can multiply straight across, or I can try to see you use some cancellation. Well, 1 and 2 is already in the lowest terms. 7 and 56, do they have any common factors? They do, because 7 times 8 is 56. So 7 goes into 7 one time. It goes into 56 8 times. Now I can do 2 times 8 gives me 16. 1 times 1 gives me 1. So 16 divided by 1 will give me 16. All right? Here I have 7/10 divided by 3/5. Remember, in division, we must invert the second fraction. So I need to rewrite this 7/10 times 5/3. Now again, I can multiply straight across. If I did, I'd get 35/30. Okay, and then I would have to do 35 divided by 30. And we could do that, or we can see if we have any common factors. 3 and 7 don't have anything common factors. We're going to get into these two numbers here in a minute as they're prime numbers. But then 5 and 10 have common factors of 5. We'll go into 5 once. 10 will go into 5 goes into 10 twice. Now I have 7/6. And when I do 7 divided by 6, I will get 1 and 1/6. Now, if I did the 35 divided by 30, I would get a 1, and I would get 30. Then I would get 1 and 5 thirtieths, but I would need to reduce the 5/30ths to lowest terms, and we would have to divide by 5, and I would still get 1 1/6. So whatever works for you, the best way is how to do it. These are different ways to do it to get the same answer, but again, I'm still following process. Step 1, step 2, step 3, before jumping into anything, before trying to solve or trying to get to the end, I have to start at the beginning. Like when running a race, you have to start at the start line. You can't just jump into a race anywhere you want to start. You must start at the start line and end at the finish. So let's talk about prime and composite numbers and exactly what they are. Okay, so we're talking about prime and composite numbers. Well, first off, we need to go to the basics. What is the definitions? The definition of prime, a prime number, not like Amazon Prime, but this is what a prime number is. And if it's a prime number, it has no factors other than 1 times itself. Say like for the number 3. The number 3, the only way to get 3 is 1 times 3. We'll talk about some prime numbers here in a minute, but this is an example. All right, a prime number has no other factors other than 1 times the number itself. Now, when we come to the word composite, you may see the word composite when talking about flowers. We have the word composite. The word itself means many parts. The word composite has many parts. A composite flower has more than one part, and that's normally where you'll see this word regularly, is when it talks to flowers, all right? But the word itself means many parts, so therefore it has other factors besides the one in itself. It has many parts to the machine, all right? We have 2 numbers here that I wrote up here that's very important to remember these as math facts. These facts will never change. The number 1 is neither, means it's not prime, and it's not composite. Therefore, it is neither one of them. It's never going to be prime, and it's never going to be composite. Now, the number 2. 2 is an even number, but 2 is the only even number that is prime, because the only way to get 2 is 1 times 2. 1 times, can't see that. How about 1 times 2? It is 1 times the number itself. See? 1 and itself. 2 is the only even number that is prime. Now I'm going to put numbers 1 through 30 up here, and we're going to decide if they are prime or composite. All right? Number 1. Okay? If we remember our math fact, 1 is neither prime or composite. So I'm going to put an X on it because it's neither. It doesn't work. All right? 2. 2 is an even number, and remember, it is the only even number that is prime. All right? So we have 3. Let me go and write a few of them up here. 4, 5, 6, 7. All right, you can see that far. All right, 3. Well, how do I get 3? Well, if I did my factors, 1 times 3. Does anything else equal 3? No. So it's prime. I'm going to put this up here so we know we are circling prime numbers. All right. 4. Well, how do I get 4? Well, 4, I can get 1 times 4 and 2 times 2. That is a composite number. So let me put a box here, and we'll say composite. Okay, it has many parts. How about 5? Well, if I had to factor out 5, I could only get 1 times 5. Does anything else equal 5? Nope. So it's prime. Now, 6. Same with 4. 4 and 6 are even. Remember, anything that ends in 0, 2, 4, 6, or 8 is an even number. Well, I already know that this is a composite number because 2 is my only even prime number. So I can go and put a box around it. And to show that, that would be 1 times 6, 2 times 3. Many parts. How do I get 7? Yes, the only way to get 7 is 1 times 7. So 7 is a prime number. How about 8, 9, 10, 11, 12, 13. Let's go to 14 on here. All right, so 8, even number. So that means it is composite. 9, all right, we have 1 times 9, 3 times 3. Many parts. Composite. 10, even. Composite. 11, I only get 1 times 11. It's the only way to get 11. Prime. 12, even. So it has to be composite. Again, I will say it. 2 is the only even number that's prime. All right. 13. How do I get 13? 1 times 13. So that has to be prime. How about 14? It's even. That's right. So it has to be composite. All right. Let's make some more room up here. I said we'd go to 30. We might stop at 20. I might make it to 30. We'll see. All right. So that was 14, 15, 16, 17, 18, 19, 20. We will stop at 20 and we'll rewrite the prime numbers 1 through 20. All right, 15. Well, 1 times 15, 3 times 5. Many parts. Composite. 16. Even. Many parts. 17. 1 times 17. Prime. 18. Even. Has many parts. It's composite. 19. 1 times 19. Prime. 20. Even. That's right. Composite. All right, let's see if we can go back and write the numbers 1 through 20 that are prime. All right, well, we won't start with 1. Why won't we start with 1? Because it's neither prime or composite. So we'll start with our first prime number, 2. The only even number that's prime. Then we said 3 was prime. We said 5 was prime. 7 is prime. Is 8? Nope. 8's even. Is 9 prime? Nope. It has many parts. 10 is even, so it can't be prime. 11, 13, 14's even. 15 has many parts. 16 is even. 17, and then 19. These are your prime numbers, 2 through 20 or 1 through 20. We don't count 1 because it's neither prime or composite. And so we have the prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. The reason we're doing this lesson is because we're going to get into dividing by prime numbers and doing a factor tree by prime numbers so that we can use our prime numbers to help us find our common factors, our greatest common factors, and our least common multiples. And again, we'll talk about factor and multiple. Factor goes into the factory. Multiple means multiply. I hope you have a great day. Stay safe this summer and enjoy the last little bit of it. Be ready for your teachers. Study hard. Like, share, and subscribe. Catch you later.